So this is my interpretation of the Antique Wireless Association capacitor DC leakage tester. I originally started building this way back in June of 2022, and most of the parts were available, maybe not immediately, but within a few weeks, except for the LR8N high voltage regulator. It was on back order literally for 13 months, and at one point I had most of this assembled and I found some on eBay, and I thought, well, probably Chinesium, but it'd be worth a try. And sure enough, they were fakes. Soldered them in, fired the thing up, and immediately had 275 volts on the output with the adjust pot all the way down. So, well, the project went on hold. Finally, a week and a half or so ago, I received the LR8Ns and put it in there, and now the unit works exactly as it should. I've got the screws off here so I can open this up so you can see the inside of it. Fairly easy to build. I'm not going to go through the whole deal on this. It didn't show the build or anything. There's plenty of good videos out there of other people, such as X-Ray Tony B and W2AEW, who did some pretty good videos on this. I just thought that I would show mine. I'm going to bolt this back together, and I'm going to demonstrate its use with a combination of good capacitors and bad ones. Okay, so the first test that I'm going to do is with a 10 microfarad 450 volt new capacitor. Hit the test switch and run the polarizing voltage up. You see how quick the leakage comes down. You want to use some common sense with this and not just bang everything with 450 volts right off the bat, even a new capacitor. But as you can see, the leakage is going down pretty quickly. It'll drop right off to nothing within just a few minutes. Usually you're supposed to hold these on for like 5 minutes to get a reading, but in the interest of time, I'm not going to do that. So that was a new one. So next up, I've got a new old stock Cornell de Bellier Beaver electrolytic capacitor from the 1960s. This is actually an unused capacitor that is probably 60 years old by now. Make sure I get the polarities correct on this. We'll see how it operates. New capacitor, but obviously old. You can see even right off the bat at 9 volts it has some leakage. That's not doing too bad actually, considering how old it is. But you can see how slow the leakage does come down. Again, you use some common sense with this thing, just jam it with 450 volts and expect it to work. And actually, it'll current limit and it'll drop that voltage down to nothing, to where you won't get to 450 volts anyways if the leakage is that bad. But as you can see, it's taking a lot longer to get to 450 volts and a lot longer for the leakage to come down. Now I'd have to wonder, I may actually do this after the video is over, if I were to leave this on, say 450 volts for 3 or 4 hours, or maybe even overnight, if this capacitor would eventually reform. I have no idea if it would or not. It may or may not. But you can see very slowly coming down, but the leakage is very high on it. And just from the interest of time, we're not going to wait for that to go down to low leakage. It might be an hour. You flip the switch over to discharge, then it discharges across a reasonably high wattage resistor. So you don't want to just flip it over to that discharge switch and then grab a hold of it. Wait a little bit, make sure the voltage goes down. Okay, this next one is also a CDE, Cornell de Billier, 8 microfarad, 450 volt. It's new old stock from the 1970s. So it's a little bit newer technology, but still an old new cap. So we'll see how it does. So the leakage is coming down quite a bit quicker on it. So it's a better cap, but still not the best. Probably could reform that one, more than likely. It would probably reform and take. Okay, now here's some stuff that I've got from items I've repaired. Mainly tube stuff that I've repaired. This one here is a 0.047 microfarad at 400 volts. Now I know for a fact the capacitance was way low on these next two, but I never really checked it for leakage because I didn't really care. I just knew the capacitance was so bad. And these are some sort of a film or paper or something. So what did I say? It was 400 volts. Okay, so let's see what the leakage shows on this. You can see already it's showing some leakage at 233 volts. So this is a bad capacitor. Anything like this that's a paper or a film type cap should basically have no leakage at all. So that one was definitely no good. If that were a electrolytic, that might be a different story, but being a film cap, it's no good. Or a paper cap or whatever. I guess it's probably more of a paper cap. This is the same one. There was two of them in this 1950s vintage clock radio that I rebuilt for a co-worker. It was his mother's clock radio when she was a little girl, and when she got married in the late 1960s, it quit working, and it had never worked until I repaired it here about a year or so ago. Basically all it had was 3 bad capacitors in it, and she was very happy to get that back and working. I need to start remembering to turn those volts down. I normally don't forget that when I'm not on camera. Too busy thinking about my video. And same thing. That's 0.36. That's 360 microamps, which is way too much for any sort of coupling cap. Way too much. Alright, and this here is the electrolytic that was in it. for the power supply. Let's see what we have. Z is the common, so that's the negative. And X is the 50 microfarad. So we'll go to the X first. And what's the voltage rating on this? 150 volts. So let's see what we've got here. Alright, so the leakage is a little bit high, but it is coming down. It's not that bad. It's coming down pretty quickly, but I know for a fact that both sections of this cap, the actual capacitance was way off. So being 50 microfarad, it's taking a little bit longer for it to leak down or drain the voltage off. So leave it on there till all the numbers are pretty close to zero. Alright, that's pretty close. Okay, and then this one here was what, 30 microfarad. Same thing, both, like I said, both of these, the actual capacitance was way off. I can't remember if it was way high or way low, but it was way, way off. But the leakage seems to be okay. Or if we were to leave this on for 5 minutes, like you're supposed to, that leakage would probably come down to an acceptable level. But still, the capacitor was no good. The bigger the capacitor is, the longer it'll take for it to discharge it. So wait until the numbers are pretty close to zero. Let's see what we've got in this one here. Yeah, we still have a little bit of charge on that one too. Alright, that's probably good. Okay, next up, I've got capacitors that I removed from my Century CT1 in-circuit capacitor tester that I refurbished a few years ago. This one here is also, it's one of those micro-mold electrolytics. Now it measures, it's supposed to be what, 20 microfarad? It measures in the nanofarads, like 5 nanofarads or something, so obviously it's no good. But I don't think I ever checked it for leakage either. I'd imagine the leakage is going to be good because it's basically open. But I'm just kind of curious. So we've got, what's the voltage in that, 350? Yeah, 350 volts. So we'll run her up to 350. Yeah, about 329 right there. And you notice the leakage really, it might be dropping down, but it's very, very slowly. Like I said, this capacitor was really bad. It was in the nano, like 10 nanofarads. So, obviously no good. And again, the leakage may have come down, but the capacitance was bad. It was way low anyways. Notice how quick those numbers went down because basically there's no capacitance left on that. Okay, and we've got here a Marbolite, good old Marbolite, 0.02 coupling cap, 600 volts. Let's See how it tests. Now the fact that it shows, the coupling cap shows any leakage at all basically means it's no good. That's one of the things I don't have yet on this. I haven't built it yet. I'm going to have 3 current ranges. The lowest current range is going to be 50 microamps, so you can really get down into the lower numbers for a coupling cap like this, a film cap or a paper cap or whatever. Now this only goes to about 597. No, it's going to go up to 600 today. Okay. Usually only about 597. You can see we've got 100 and some microamps of leakage, so that cap's no good. And we've got one more here. Same thing, I believe. Well, it's a good all type M 503.01 microfarad, 600 volts. We'll see how it does. See, it's a little bit better, but still, if there's any number there at all, I tested in the particular range that this is in right now. I tested it, it'll bring up a 1 at 12.3 microamps. So anything that's a 1 is over 12 microamps. And we're heading towards a 2. Okay, so there's 600 volts. So again, that cap leak is way too leaky. And same deal with the other one. With some of these other ones, the capacitance was way off. That's the main reason I replaced them anyways. The capacitance was way off. So I'm going to put these away, and then I'm going to pull up that Antique Wireless site on my laptop here so you can get a look at how you could buy one of those. I'll be back. Okay, so here's the website where you can pick up the PC board for this. You get a PC board, and then also you get a parts list, and they show example of one that's already been built, and talking about the LR8N3G regulators. I do know for a fact that they are out of stock again. I just put an order in for 10 more so I could have some if I have another project similar to this in the future. And they're supposed to be here in September, which is a lot better than 13 months like the last time. I'll just slowly scroll this up so you can read it if you want to, or just go to the website. There's a few instructions on what they use for a test procedure. Like I said, you get a parts list and the PC board, the bare board, and this the $25 for this goes to supporting the Antique Wireless Association, so it's a good good cause. So if you do happen to want to build this, hopefully I gave you a little bit of information to make it easier.